In today's Wise SCADA lesson, we will cover the alarm topic. For the alarm, first, let's add a new alarm group by clicking on New. In the opening window, we are adding a new alarm line by clicking on the New button again. First, let's start with the tag selection. Tag 1 is a Boolean type tag, and I am writing true inside quotation marks as the set value. As you know, the value of bit type tags can be true or false. In the current configuration I made, this alarm will be triggered when tag 1 is true. We can also see the alarm message here. Let's run our first alarm immediately. We use the alarm view object in the screen to monitor alarms. I added one alarm view object to the page. Since the tag value is a Boolean type label, we will set it via a checkbox and monitor it. I selected tag 1 and I am running runtime. When the checkbox is checked, the alarm came. As seen, when the check is removed, the alarm went away and became a different color. It is observed that the alarm comes back when checked again. I will explain the alarm view object later. Now let's continue from the Alarm Manager section regarding the configuration of alarms. I am adding a second alarm. I will select the label again. Tag 2 label. This time, instead of writing a fixed value in the set section, I configured the configuration. To generate an alarm if tag 2 is equal to tag 1 by selecting tag 1. Additionally, I want to select a different tag in the display tag column. Likewise, I selected a different tag for display set. Now I am adding objects where I can monitor these tags on the screen. Let's add two text boxes. I select tag 2 for the checkbox object from the value section, tag 4 for the text box object, and tag 5 for the other one. And I am starting runtime. Now let's give them a value. I broke the equality, now the alarm is gone. The alarm came when I provided the equality again. We saw the value of the tag I selected in the display value section here, and the value of the tag in the display set section here. Generally, we use bits when creating alarms in PLC programs. For example, when a temperature value exceeds 100 degrees, we run a timer. If it has exceeded this value for 10 seconds, we ensure the alarm is generated by setting a bit. In this case, there is no point in seeing the value of this bit, that is, the true, false value inside the alarm view. What we really want to see is the temperature value. At this point, we can show display tag and display set values. Now I want to explain the hysteresis topic. For hysteresis, I first selected a non-Boolean numeric tag, and I entered its value as 10. I entered 3 for the hysteresis part. Let's put the greater than or equal sign in the expression section. What does this mean? The alarm will come when the value of tag 4 is greater than or equal to 10. But for the alarm to go away, it must have gone below 10 minus 3, that is, 7. Thus, we prevent the alarm from frequently coming and going in analog values. Now when I make it 11, this alarm came. Let's even break that equality. Let's remove the other alarm too. Now when I make this 9, the alarm is still visible on the screen. It is still visible when I make it 7. The alarm went away when I made it 6. By using hysteresis, we can prevent analog alarms from frequently coming and going. We can define different colors for each alarm. We can make different definitions such as the background color of the cell and the font color when the alarm is active. We determine the color the alarm will take when seen by the operator via scene color. We can adjust the color it will take when the alarm condition disappears, that is, when it returns to normal, from the normal color column. Let's explain the Bitwise event as well. When we check the Bitwise property of an analog alarm, by writing its bit number. For example, we can make a definition here such as alarm should come when the first bit is true. Here, depending on the type of this variable, we can create a different alarm for each bit by writing a bit number between 0 and 63. Let's explain the enable topic as follows. First, let's delete the other alarms. Let there be 1. This alarm will come when it is greater than or equal to 10, however, we can add a second condition to this. Let our condition be this. If the value of tag 1 is true, this alarm should be tested and shown on the screen when it comes. If the value of tag 1 is false, the alarm should not be checked at all, nor shown on the screen. Let's try it immediately. First, let's delete the old alarms from here. Let's give the value 15. As you can see, the alarm did not come because there was no enable bit. When we provide the enable bit, the alarm comes normally and becomes available. Let's give the alarm again. Let's remove the enable bit. Now all alarms associated with this bit will appear as if they are gone. This enable operation can be done individually for each alarm, as well as defined within the group alarm, that is, to disable the entire group, all alarms in this group. Where do we use this feature? For example, we have alarms related to the generator, but these alarms need to be shown when the generator is running. If the engine is not running, these alarms should not be checked. In such a case, we can use the enable bit. When we click here, that is, when we click on the alarms heading, we will see all the alarm groups we created under alarms as a row here. We select a variable of bit type for activate alarm. If there is any alarm in this group, this bit becomes true. If there are no alarms, it becomes false. For example, let's add an alarm lamp to the screen. And let's select a tag here so that it is visible if there is an alarm in the group. That alarm lamp will appear if there is an active alarm in this group. Unacknowledged alert becomes true when there is an alarm in this group that the operator has not seen. It becomes false if the operator has seen all alarms in this group. Let's also examine this section where printer-related settings are made. Today, modern printers print a page as a full page. However, a normal printer can also be used here. A Dotmatrix printer can also be used. When a Dotmatrix printer is used, every incoming alarm prints a line. It prints a line when the alarm goes away as well. Dotmatrix printers continue to be used in different sectors such as ships where safety is a priority. Now let's continue to examine the alarm view object where we monitor alarms. You know we used it in the screen. Let's close this. The alarm view object is an object where we can monitor all alarms. You can change the texts on the object, column headers, and all other information from this section. For example, let's change the value written on this real-time button. The real-time button is here. And I come to its text property. I changed it to Fluctuations. The text changed. You can change the text as well. You can also change the images. You can change their coordinates on the screen. To prevent operator confusion, displaying so many columns on the data grid might not be necessary. In the options in the result grid column header, for example, we ensure that the ID number is no longer visible by setting its visible property to false. Let's change the name of the second column, group number, to just no. You can change these names according to different languages. You can also learn all of this by reading from the help pages. The most critical settings here are the combo boxes named Dynamic and Group. Let me explain these. It would be better to explain the dynamic mode in runtime. In dynamic mode, generated alarms continue to remain on the screen even if their conditions return to normal. For example, the alarm is gone but it continues to stay on the screen. Because this alarm has not been acknowledged yet. We can select only the relevant alarm line and say acknowledge, or we can say acknowledge for all alarms. The moment we say acknowledge, old alarms are deleted from the list. The color of the active alarm changes but it continues to remain on the screen. When the condition becomes invalid, it will go directly from the screen. This is the dynamic working method. When we select the All method, all alarms that have come, are active, have gone, or have been acknowledged will be included in this list. When active is selected, only active alarms are shown. Alarms that are gone do not appear in this list. In historical, you can only see past alarms, deleted alarms. Active alarms are not shown. Again, this list is live. When an alarm comes and goes, this list works live even when historical is selected. When we select acknowledge, only acknowledged alarms appear in this list. The coming or going of the alarm is not important. The list is refreshed only when we say acknowledge. If we touch upon the group topic, we currently have one alarm group here. Let's assume we have two alarm groups. Let's quickly define an alarm group. Here, with group selection, only alarms in the first group. Or by changing the selection, only alarms in the second group can be monitored. Or we can monitor all alarms by saying all group. Currently all group is selected. We can also define this as a fixed group. We can select the group we want to show from the fixed group section in the advanced panel. Then, by setting the visible property of the group combo box to false, we prevent operators from seeing this. One of the most important issues is that in many automation applications, operators do not use the acknowledge option for alarms. Therefore, the list on the screen constantly lengthens and becomes a large list. In this case, manual confirmation by the operator must be made mandatory by using the acknowledge option during alarm definition. When you select auto, the alarm is automatically deleted from the list when it goes away. By associating this with a tag, when the value of this tag becomes true, this alarm becomes acknowledged. And it is automatically deleted from the list. Our lesson regarding alarms has ended. Thank you for watching.